Hi friends, in this video we are going to learn about response of a system. So we can find response of a system in two ways, by solving the difference equations and then by solving the convolution sum. In this video we are going to learn how to get the response y of n of a system using convolution sum. So as we already know, convolution is given by y of n is equal to summation minus infinity to infinity x of k into h of n minus k. So we'll get the more information by solving by example, and by solving difference equations we'll discuss it in the later video. Now consider the given example. Given example, x of n is 3, 2, 1, 2. H of n is 1, 2, 1, 2. Okay. Now they are asked to find the convolution sum or the response y of n. So here what we do is we apply the convolution property for both the signals and we find the output y of n. Now as you can see, this is the sequence representation of a discrete signal. As we already know that a discrete signal can be represented in sequence form, tabular form, graphical form. Okay, so this is a sequence representation where this arrow mark indicates the zero position of the discrete signal. That means at zeroth position, zeroth sample, the amplitude is 3. At zeroth sample, the amplitude is 2. So when we try to solve this in a graphical manner, we have as arrow mark is on 3, so 0, 1, 2, 3. This is graph for x of n. Now h of n will be (1, 2, 1, 2). The starting position is -1 and 2 is at 0, so 1, 2. This is h of n. Now as per the convolution, it is summation of x of k into h of n minus k. That means we need to shift the signal. Now first we need to change the domain from n domain to k domain. So let this be in k domain. I need h of n minus k as a product. So first I need to apply the time reversal property. So it will be h of minus k. Just don't change the amplitudes of their respective samples, just change the time periods. So this will be -2, -1, 0, 1. Now see, it is, when this comes here, 2, 1, 2, 1. This is h of minus k. Now we got x of k and we got h of minus k. Now we need to start with h of n minus k. First we need to know what is the starting point for the convolution. Now if you can see here, the x of n starts at 0th sample, but whereas h of n starts at -1th sample. So overall the convolution starts at -1. This is the main thing. Next thing is, total samples in the first signal are 4. So the total samples in the second signal are also 4. According to the property of the convolution, if the number of samples in output signal will be n1 samples of first signal, n2 samples of second signal -1. That means here 4 plus 4 minus 1, we get 7 samples in the output for these 8 samples. Okay, now we'll try to start convolution. So as first signal starts at -1, we need to go with h of -1 minus k. So n is minus 1 here. So I am doing shifting the signal by minus 1 times. So what we get is add minus 1 to each signal. We have 2 minus 3, 1 at minus 2, 2 at minus 1, 1 at 0. Now apply x of k convolve with x of k into h of minus 1 minus k. As you can see here, both this is from minus 3 to 0 and this is from 0 to 3, and the only intersection point for x of k and h of minus 1 minus k is at 0. At 0 this amplitude is 1, at 0 this amplitude is 3. So when we get the product, we will get at y of 0. At 0 it is 3. Now similarly, go on shifting to right side. Now the next example will be h of minus k into x of k. Now after n equal to minus 1, we are going for n equal to 0. When n equal to 0, y of 0, already h of minus k is there here. So directly at 0 its value is 2, at 0 its value is 3. So 3 into 2, 6, plus at 1 its value is 2, at 1 its value is 1. 1 into 2 is 2. This is 8. Y of 0 equal to 8. Because they are n equal to 0. Now next, we are shifting the signal by 2 time units. Or else we are shifting from left side 2 time units. That means it will be h of 1 minus k. Minus 1, 0. Now 1, n equal to 1. When we do h of 1 minus k to the signal, it will be, you add 1 to this. That means you are adding. Now the signal starts from minus 1 to at 0 it is 1. Now at 1 it is 2 again, and it is 2 at 1 again. So I am just adding 1 to time samples. It becomes minus 1 to 2. Now again apply x of k product with h of 1 minus k. This will be at n equal to 1. So y of 1 will be, now you can see the intersection point for these two are 0 and 1, 2. 0, 1, 2. At 0 it is 1, at 0 it is 3. 1 into 3 is 3. At 1 it is 2, at 1 it is 2. So 4. 2 into 2, 4. At 2 it is 1, at 2 it is 1. So 1. It will be 8. Y of 1 will be 8. Now similarly, if we go for y of h of 2 minus k, the signal will be starting at 0 and ending at 3. 1, 2, 3. Now the intersection points will be 0, 1, 2, 3, 0, 1, 2, 3. We get directly y of 2 will be 3 into 2 plus 1 into 2 plus 2 into 1 plus 2 into 1. 2 plus 2 plus 2, 6. 6 plus 6, 12. We get y of 2 as 12. Similarly, now shift the signal by 3. 3 time units. Now signal starts at 1 and ends at 4. Similarly, go on increasing this value to 4. Now the signal starts at 2 and ends at 5. Now go on increasing to 5. Now the signal starts at 3 and goes to 6. Now up to here we will be having the intersection point, because at 3 it is 2, at 3 it is 2. Now if you increase by 6, now the signal will be starting at 4 and ending at 7. So no intersection between x of k and h of minus k. So we get y of minus 1, 0, 1, 2. We get y of 3. We get y of 4. We get y of 5. But from y of 6 onwards it will be 0. Y of 7, y of 8. All the terms from after y of 5 will be 0. We'll get the terms up to y of 5. Okay. Now even you can check the result by applying a simple trick. You can check the result whether it is correct or not by applying a trick like this. Place x of n values here and h of n values here. So x of n is 3, 2, 1, 2. X of h of n is 1, 2, 1, 2. Now apply the product. 1 into 3, 3. 1 into 2, 2. 1, 2. 2 into 3, 6. 2 into 2, 4. 2 into 1, 2. 2 into 2, 4. 1 into 3, 3. 1 into 2, 1, 2. 6, 4, 1, 2. Now apply diagonal matrix. Only consider diagonal elements. 2. Okay. To the 4. Right. So if you can see, this is the first value we got, y of 0 as y of minus 1 at starting point as 3. Next value is 6 plus 2, 8. Next value is 3 plus 4 plus 1, 8. 6 plus 2 plus 2 plus 2 is 12. Next value will be 4 plus 1 plus 4, it's 9. Next value is 2 plus 2, 4, and next value is 4. By that we can verify what are the values we got from y of minus 1 to y of 5, whether it is correct or not. This is another method of doing the conversion. So I hope all of you have understood this. Thank you all.